Welcome to the Joy of Architecture. Today we're really diving deep into something pretty ambitious. It's one of the most aspirational goals in software development, I think. Achieving true continuous deployment. Now, what do we actually mean by true CD? Well, we're talking about a world where every single successful code change, it just automatically goes live, right into production.
Exactly.
Automatically.
No human intervention needed.
Zero. That's the key difference. It's really the zenith of agile delivery. Promises incredible speed, innovation.
And super fast feedback from actual users.
Right. But it's important to clarify, how it differs from related terms.
Good point.
So continuous integration, CI, that's the baseline, right? Frequent code merges, automated builds, automated tests.
The foundation.
The foundation.
Yeah.
Then you have continuous delivery, also CD, which builds on CI. It gets the code ready automatically, so it could be deployed at any time.
But someone still has to push the button. Exactly. There's still that manual gate, that human decision point before production. True continuous deployment. It eliminates that final gate. If the pipeline says green, it goes live.
Yeah.
Period.
Wow. That takes some serious confidence.
Oh, absolutely. It demands an unwavering belief in your tests, your automation.
Yeah.
Just an exceptionally high degree of confidence in the whole pipeline.
And strategically, why chase this? It's not just about going fast, is it? It's faster time to market, obviously, but also that accelerated feedback loop. You learn what users need, like, now.
And you can respond almost instantly. Plus, think about risk.
Right. Smaller changes, more often.
Exactly. Smaller blast radius if something does go wrong. Easier to pinpoint, easier to fix quickly.
So our mission today is basically to give you, our listeners, a shortcut. Help you understand the hurdles, technical, strategic, cultural, and figure out what really matters to get unstuck if you're sort of midway on that DevOps journey. Okay, let's start unpacking the technical side. Where do teams usually hit the first big snags?
Well, often, it starts with something seemingly small, but incredibly insidious. Flaky tests.
Ah, the dreaded flaky tests. Explain those for us.
They're tests that just aren't consistent. They pass sometimes, fail other times, even when absolutely nothing in the code has changed.
So they're non-deterministic.
Exactly. Imagine debugging that. It's a nightmare. And worse, they allow real bugs to sneak through because people start ignoring failures. The boy who cried wolf scenario.
That sounds like a complete confidence killer for automated deployment. You can't trust the signal.
Precisely. And it totally undermines the whole point. If you can't trust your automated quality gates, what happens?
You put the manual checks back in.
Right. And you've defeated the purpose of true CD.
So what causes them? Bad tests, environment issues.
It's often a mix. Poorly written tests, maybe with hidden assumptions about timing, or asynchronous stuff where the test just doesn't wait long enough, or tests messing with each other because they share resources and don't clean up properly, concurrency issues, environment inconsistencies, lots of potential culprits.
And fixing them. Is it just about tweaking wait times?
Sometimes that helps, or adding automatic retries as a Band-Aid. But fundamentally, you need to find the root cause. Make tests truly isolated. Ensure environments are pristine for each run. Maybe use mocking more effectively. Sometimes you have to temporarily mute a really problematic one while you fix it properly.
So dealing with flakiness isn't just test maintenance. It's like foundational trust repair for automation.
That's a great way to put it. It's an absolute prerequisite.
Okay, what's next on the technical hit list? Slow CI/CD pipelines. This one feels personal for a lot of developers, I bet.
Oh, definitely. It's not just a technical problem. It's a human problem. Slow pipelines crush developer experience.
Yeah, waiting ages for feedback. It kills productivity, morale.
Leads to burnout even. And crucially, it undermines trust in the process. If the fast lane is actually slower than just doing it manually, guess what happens?
People find ways around it. Shadow IT, manual deploys.
Exactly. They bypass the very automation you're trying to build. Common bad practices. Treating CI/CD as set it and forget it, letting pipelines get bloated over time.
Running all the tests every single time, maybe.
Yeah, massive test fatigue. Or just ignoring pipeline feedback, letting bottlenecks build up, overcomplicating things.
So how do you speed them up? Just more hardware?
Sometimes, but often it's about optimization. Regularly review and prune your pipelines. Segment tests, run quick unit tests first, then maybe integration. Save the full end-to-end for later stages or specific triggers.
Parallelize things.
Definitely. Parallelize stages, parallelize tests. Enforce a fail-fast approach, find problems ASAP. Simplify, modularize the pipeline. Actively hunt down bottlenecks, whether it's slow tests, long code reviews, or manual steps.
So optimizing pipeline speed isn't just about efficiency numbers, it's actually cultural. It's about getting developers to want to use the system.
It's a critical cultural enabler, absolutely. You need their buy-in. You need them to trust the flow. And this connects to another big one, complex dependency management, especially with microservices.
Ah, yeah, the promise of independence, but then dependency hell.
Right. You can end up with tight coupling anyway, versioning nightmares, network latency issues popping up, coordinating deployments becomes a huge pain.
Testing and isolation gets really hard.
Exactly. You end up with what some call a monolith of dependencies. All these supposedly independent services are actually tangled up, like spaghetti.
So how do you untangle that spaghetti? How do you stop dependencies derailing your automation?
Well, automation helps during the build itself. Tools can automatically download dependencies, check compatibility, run crucial vulnerability scans. Think those like SNCC, OWASP dependency check, retire.js.
Okay, so standing helps.
It does, but you still face challenges. Maybe a huge volume of pull requests from automated dependency updates,
Yeah.
or breaking changes sneaking in, false positives from scanners.
So best practices, what should teams focus on?
Visibility is key. Know what you depend on. Embrace loose coupling architecturally. Use service discovery effectively. Semantic versioning is crucial. Implement patterns like circuit breakers to contain failures.
Fail fast in the pipeline if a dependency issue arises.
Absolutely. Comprehensive automated testing around dependencies is vital. Regular audits, maybe using a software bill of materials, an SBOM. Dependency injection helps manage things programmatically.
Right, because unmanaged dependencies, they just create this cascading risk, don't they?
Completely. It contradicts the whole idea of small, frequent, independent changes that true CD relies on. It reintroduces friction.
So dependency management is really about managing the blast radius of change.
Precisely. Containing issues, catching them early.
Okay, one more technical area. Infrastructure and code-base specific challenges. You mentioned the YAML problem with Kubernetes.
Yeah, it's partly that YAML itself doesn't have a standard package manager like, say, Java or Node. And testing those YAML configurations, especially complex Kubernetes manifests, locally before they hit the pipeline can be tricky.
And environments drifting apart, dev versus staging versus prod.
That's a huge one. Environment standardization is often overlooked, leading to inconsistencies that only show up late in the game.
So what are the solutions here? Treating infrastructure as code.
Exactly. Infrastructure as code, or IAC, is fundamental. Using tools like Terraform, CloudFormation, Google Cloud Deployment Manager, that ensures consistency, and then applying software practices to that IAC. Static analysis tools can inspect configurations for defects, vulnerabilities, compliance issues without running anything.
Like linting for infrastructure.
Sort of, yeah, but often more powerful. Checking against OWASP rules, CWE vulnerabilities, and differential analysis, like Clockwork offers, can give really fast feedback just on the changes you made, which is great for large IAC code bases. Automated configuration management tools also play a role.
What's really fascinating here, as you said, is that infrastructure code needs the same rigor as application code.
It absolutely does. If you can't easily and automatically test your infrastructure definitions within the pipeline, they become a huge source of risk. That undermines the confidence needed for fully automated deployment.
So the definition of code has to expand.
It has to encompass all configuration, all infrastructure definitions. Only then can you really automate deployment with confidence.
Okay, that covers some major technical hurdles. Let's shift focus. Building the confidence needed for true CD often means shifting quality, earlier the shift left approach.
Absolutely fundamental. Shift left is all about moving testing activities much earlier in the product lifecycle, into development, even into the design phase, making quality assurance continuous, not an afterthought.
And benefits.
Huge. You find and fix issues proactively when they're far simpler, less complex, and significantly less expensive to fix.
Right, fixing a bug in dev is way cheaper than in prod.
Orders of magnitude cheaper. It also enhances overall quality, speeds up delivery because you have fewer late-stage surprises, and improves security by catching vulnerabilities early.
So it's not just tweaking the process, it's a mindset change.
It's a fundamental cultural and mindset transformation. Quality isn't something checked at the end. It's built in from the start. It becomes a shared, continuous responsibility for the entire team.
Everyone owns quality.
Exactly. In true CD, you absolutely must build quality in. You shift from detect and fix late to prevent early.
Let's break down the testing types that enable this. Foundational stuff first. Unit and integration tests.
Right. Unit tests are the bedrock. They isolate and verify individual pieces of code, a function, a method, a class.
Benefits. Early bug detection.
Yep. Improves code quality because you have to write testable code, speeds up development with fast feedback, reduces overall cost. The challenge is getting good, comprehensive coverage.
And best practices for unit tests.
Write testable code from the start. Test early, test often, automate them completely. Keep tests small, focused, and fast. Use mocking effectively for external dependencies. Then integration tests look at how different modules or components interact. Do they play nicely together?
So verifying the connections.
Exactly. Helps maintain a stable code base as things change, gives immediate feedback on integration points, reduces risk. Best practices here include automating builds, frequent commits, fixing broken builds immediately.
Fast, reliable tests are key again.
Always. Maybe use multiple test suites for different scopes. And creating on-demand test environments, perhaps using Docker, is super helpful here.
So these unit and integration tests, they're the base of that testing pyramid, enabling the fail-fast idea.
Precisely. They provide those rapid feedback loops that are absolutely essential for quick iteration and building the confidence you need to eventually remove those manual approval steps. Without solid unit and integration tests, your pipeline either breaks constantly or nobody trusts it.
Okay, moving up the pyramid, or maybe sideways, advanced shift-left techniques. Let's talk contract testing.
Contract testing is really interesting, especially for microservices. It's about verifying interactions between services based on a shared understanding, a contract.
A contract for APIs, inputs, outputs, behavior.
Exactly. Each service checks that it adheres to the contract it has with other services. The huge benefit is it prevents integration failures without needing to spin up all the services together.
So it enables independent deployment.
Yes, which is crucial for microservice velocity. And it gives much faster, simpler feedback than traditional heavy end-to-end tests because you don't need that full application instance.
And static analysis. We touched on it for IAC, but for application code.
Same principle. Analyzing the source code without running it. Looking for potential bugs, security vulnerabilities, think OWASP POP10, CWEs, and adherence to coding standards.
Finds things like memory leaks, concurrency issues.
Potentially, yes. It offers really early issue detection, can find problems that are hard to catch with dynamic testing, and helps enforce consistency and compliance. Tools like Clockwork, using differential analysis, give quick feedback even on huge code bases.
So both contract testing and static analysis are key for true CD because
They offer proactive, lightweight validation at scale. They check interfaces and code quality early, reducing the burden on slower, more complex tests later in the pipeline. They let you maintain higher velocity by catching issues right at the source. And we should definitely mention test-driven development, TDD.
Right, the red-green refactor cycle.
Exactly. Write a failing test first, red. Write the absolute minimum code to make that test pass, green. Then clean up the code refactor.
What are the big wins with TDD?
Again, super early defect detection. Fixing bugs when they're just introduced is trivial compared to later. It naturally leads to better, more modular code quality because you only write code to satisfy a specific test. Continuous feedback is built in, facilitates collaboration.
It sounds like it really changes how developers approach quality.
It fundamentally does. It embeds quality into the very act of coding. It fosters a quality-first mindset, which directly helps reduce that fear of deployment by building confidence right from the start.
And there are plenty of tools out there to support all this, right? Our sources mention things like Selenium, Junit, PyTest, Cypress for testing.
And OSV Scanner, SNCC, Trivy for vulnerability scanning and dependencies,
Trufflehog for secret scanning, Checkov or Snike for IAC misconfigurations.
SonarCube for overall code quality. The tooling ecosystem is rich.
Okay, now for what feels like one of the trickiest areas in true CD, end-to-end testing, E2E.
Yeah, E2E testing is definitely a challenge. Its purpose is vital, evaluating the entire application flow, mimicking real user journeys from start to finish. It's often the last line of defense before production.
They're slow, brittle.
Often, yes. They are typically the most complex, time-consuming, and resource-intensive tests. They have the longest execution times, they can be prone to flakiness due to their complexity and dependencies, and they easily become major pipeline bottlenecks.
So it's a paradox. You need them for confidence, but they slow you down, which hinders CD.
Exactly. The solution isn't usually to just ditch them entirely.
Yeah.
It's about being strategic. How do you balance comprehensive coverage with the need for speed?
How do you do that?
You prioritize ruthlessly. Focus pre-deployment E2E tests only on the absolute critical user paths, the most essential business flows. Optimize their execution, Maybe use mocks for slow external services, pre-configure test data, run tests concurrently where possible, and absolutely automate them.
So it's not about running all E2E tests before every deploy. It's more granular, optimized, maybe run some after deployment.
Precisely. It's an intelligent risk management approach. Maybe run a smoke suite of critical E2E before, and the full regression suite afterwards, perhaps in parallel or against a canary instance.
This sounds like where ephemeral environments could be a game changer. Tell us about those.
Right. Ephemeral environments are temporary, isolated testing environments. They get automatically provisioned for a specific test run, maybe for a single pull request, and then torn down afterward.
Instead of a shared static staging environment.
Exactly. The advantages are huge, dramatically faster feedback loops because each change gets its own dedicated environment immediately. True parallel testing becomes feasible across many isolated environments simultaneously.
Cost savings too, presumably. Pay for what you use.
Significant cost savings compared to maintaining large static staging environments. Plus, better collaboration asynchronously and improved consistency using tools like Docker and Kubernetes to define the environments.
So ephemeral environments directly tackle that bottleneck problem.
They do. They shift infrastructure from static to dynamic, on demand. This drastically cuts E2E execution time and removes the environment itself as the point of contention. They are a truly transformative enabler for automated E2E in a true CD context. Another key tactic is the strategic use of mocks and stubs.
To simulate dependencies.
Exactly. Simulating external systems like databases, third-party APIs, things you don't control or that are slow or unstable. This allows you to test your component in isolation.
Benefits.
Speed, obviously. Speed and efficiency, definitely. You don't need the real external system. Also improves test reliability by isolating the code under test from external factors. And it decouples development teams can proceed even if a dependency isn't ready yet.
So even in E2E testing, you might mock certain things.
Strategically, yes. For non-critical external systems or notoriously unstable dependencies, it helps reduce execution time and flakiness. Some tools can even record real interactions and replay them in tests.
So it's a pragmatic balance. Get most of the end-to-end flow, but smartly mock things that cause disproportionate pain.
Exactly. It's about balancing comprehensive testing with the speed requirements of true CD. Faster, more stable pipelines are the result.
Okay, one more technique in this area. Proactive monitoring with synthetic tests.
Right. Synthetic monitoring involves simulating user interactions with your application, often from different geographical locations, on a continuous basis.
So automated scripts acting like users.
Essentially, yes. They proactively check key workflows 24/7. The goal is to identify issues like performance regressions, broken features, availability problems before real users are impacted.
How does this fit into true CD?
It acts as a continuous validation check. After deployment, synthetic tests can immediately verify if the new code introduced any regressions or bugs on critical paths before you scale up a canary or flip the switch on a blue-green. It also helps ensure you're meeting SLAs.
So it complements E2E tests ran earlier.
It does. Synthetic tests are often more focused and provide quicker feedback on specific components post-deployment, while E2E provides broader validation earlier. Synthetics are like a final, continuous check in production.
Like extending shift left, right into production monitoring.
That's a great way to think about it. It's a continuous automated canary in the coal mine for user experience. It's really the ultimate last line of automated defense and a key part of the feedback loop that builds confidence to remove those manual gates. Not a luxury, a necessity for true CD. All right, deploying automatically means we need really robust safety nets and visibility. Ensuring safety and transparency is paramount.
Let's dig into the advanced deployment strategies. These are all about limiting the blast radiuses, right? Introducing changes carefully.
Exactly. Minimizing risk and disruption. First up, canary deployments.
Releasing to a small group first.
Yep, maybe 1%, 5% of users get the new version initially. You monitor closely. If things look good, you gradually increase the percentage. If not, you roll back just that small group. Low risk, fast feedback from real users.
Okay, then blue-green deployments.
Here you maintain two identical production environments. Let's call them blue, currently live, and green, the new version. You deploy the new version to green, run tests there. When ready, you switch the router to send all traffic to green. Green becomes the new blue.
And the old blue is kept ready for rollback.
Instantly. Minimal downtime, instant rollback. The main considerations are the cost of duplicate infrastructure and potential data consistency issues during the switch. Then there's shadow deployments, also called traffic mirroring.
This sounds interesting. How does it work?
The new version runs alongside the live version. It receives a copy of real production traffic, processes it, but its responses are just discarded. Users are completely unaffected.
So you're testing the new code with real, live traffic under load, but with zero risk to users.
Exactly. Amazing for testing performance, scalability, and feature parity before going live.
Yeah.
You do need to consider data protection, maybe anonymizing sensitive data in the mirrored requests, and monitoring the extra resource usage.
And finally, feature flags or feature toggles.
These are powerful. They let you enable or disable specific application features at runtime without deploying new code. You deploy the code containing multiple features, but keep some off via flags.
So you decouple code deployment from feature release.
Totally. You can then turn features on for specific users, do A/B testing, perform progressive rollouts, and instantly turn a feature off if it causes problems, all without a new deployment. The main challenge is managing the flags themselves. They can become technical debt if not cleaned up.
Wow. These strategies really feel like the core of managing risk in true CD. They turn deployments into controlled experiments, not big bang events.
They are the cornerstone. They provide the safety nets, the ability to reverse or contain issues quickly. They directly combat that fear of breaking production and help build what I call calibrated confidence trust that's based on demonstrated safety, allowing you to remove those manual gates. And hand in hand with these strategies, you absolutely need robust and automated rollback mechanisms.
Being able to undo a deployment quickly if things go wrong.
Critical. It's a fundamental business continuity requirement. You need to be able to rapidly revert to a previous known good state to minimize downtime and impact.
Are there different kinds of rollbacks?
Sure, you might do a full rollback of the entire deployment. Or maybe a partial rollback if you can isolate the problematic component. Or, if using feature flags, the rollback might just be flipping the flag off.
And the key is automation.
Automation is crucial, but equally crucial is regularly testing your automated rollback procedures. Do they actually work under pressure?
Like a fire drill for deployments.
Exactly. You also need thorough documentation, clear communication plans, designing processes to be idempotent and reversible where possible, storing versioned artifacts in IAC, and having automated health checks that can actually trigger the rollback.
So automated rollbacks aren't just a technical feature, they're a psychological safety net too.
Absolutely. They're the ultimate safety valve. They transform the fear of failure into confidence in rapid recovery. This lowers the perceived risk of automated deployment, making the organization much more comfortable removing manual approvals. It also enables a fix-forward approach more often.
Instead of rolling back, just deploy a fix quickly.
If the issue is small and the fix is ready, yes. Because your deployment process is so fast and safe, pushing a fix forward can be quicker and less disruptive than a full rollback.
Okay, safety nets in place. Now, visibility. Comprehensive observability. Metrics, logs, and traces.
Observability is the sensory system for true CD. Without it, you're flying blind. It provides that real-time, data-driven feedback loop that allows automation to proceed without constant human oversight. If you deploy something broken automatically, you need to know immediately.
And it's built on those three pillars.
Right. Metrics. Numerical data about system activity. Think CPU usage, latency, error rates, and especially the vital DORA metrics.
DORA metrics.
Deployment frequency, lead time for changes, change failure rate, and time to restore service. These measure the health and performance of your software delivery process itself.
Okay, pillar 2, logs.
Chronological, time-stamped records of events that happened, what occurred, when, maybe why. Ideally structured for easier analysis.
And pillar 3, traces.
Traces track a single request as it flows through all the different services in a distributed system. Essential for understanding performance bottlenecks and errors in complex architectures.
What are the best practices for building good observability?
You need to shift left observability too. Think about what needs monitoring early in development. Standardize tooling where possible for unified views. Use AI for diagnostics if you can. Tie observability into your deployment strategies, like progressive delivery. Create clear feedback loops. Foster collaboration between teams using this data. Focus on critical metrics. Don't drown in noise. And automate your monitoring setup using IAC.
So observability is really the enabling feedback loop for true CD. It builds confidence based on real data.
It's the critical feedback loop. It allows rapid, informed decisions. It builds empirical confidence. It tells you not just if something broke, but ideally what, why, and where, allowing automated rollbacks or fast human intervention. It's fundamental for maintaining trust in the automated process. And the final piece of this safety puzzle, integrating security. throughout the pipeline. DevSecOps.
Because going faster can't mean being less secure.
Absolutely not. With the speed of true CD, vulnerabilities can get pushed to production just as quickly as features. Proactive, shift-left security becomes non-negotiable. Too many teams inadvertently skip security checks in the name of speed.
So again, shift left security, build it in.
Embed security checks at every stage. Key automated tools and practices include static application security testing, say SAC, scanning code for flaws,
Dynamic application security testing, BAS, testing the running application.
dependency scanning for known vulnerabilities, CVEs, in libraries, configuration linting or scanning for your IAC, secret scanning to find exposed credentials in code.
Best practices here, beyond just running the tools.
Schedule periodic security regression tests. Integrate security tests early in the pipeline. Verify external packages and dependencies. Prefer minimal base container images. Automate dependency updates with scanning. Maintain that software bill of materials, SBOM. Implement continuous security monitoring in production too.
So security in true CD has to evolve from being a gatekeeper to being an embedded capability.
Exactly. An embedded, continuous, automated capability. It requires that DevSecOps cultural shift where security is truly everyone's responsibility. You can't trade velocity for security or compliance.
Right. These technical and safety aspects are huge, but often the biggest hurdles aren't technical at all, are they? They're cultural and organizational.
That's absolutely true. While the tech is challenging, the most formidable impediments often stem from human dynamics and organizational structures.
Let's unpack the first one, overcoming resistance to change and fostering a learning culture.
Yeah, true CD is a fundamental change to how organizations work. It often triggers fear of jobs changing, fear of becoming obsolete, or just a preference for the way things have always been done, even if it's inefficient.
Inertia, like the Blockbuster example you mentioned, failing to adapt.
Exactly. That resistance prevents organizations from capitalizing on the benefits. Overcoming it needs a multifaceted approach. Clear, consistent communication about the why, the how, the what's in it for everyone. Visible sponsorship from leadership is crucial.
Getting people involved early, training.
Definitely. Early involvement, training, support, but most importantly, you need to cultivate a learning environment.
What does a learning environment mean in this context? How does it help with CD?
It means shifting away from a culture of blame. When mistakes happen, and they should be treated as opportunities to learn and improve, not occasions for punishment. Encouraging open discussions, blameless retrospectives.
Psychological safety.
That's the key term. Creating an environment where people feel psychologically safe to experiment, to try new things, to admit errors, and to learn from them without fear of severe repercussions. This promotes a fail-forward mindset.
So resistance is often fear. True CD removes manual safety nets, which triggers fear of messing up in production.
Precisely. That fear can lead people to undermine the automation, consciously or unconsciously. Building psychological safety allows people to trust the process, trust their colleagues, and trust that failures will lead to learning, not blame. That's essential for automation to truly flourish.
Next barrier, breaking down organizational silos and cultivating cross-functional collaboration. The classic dev versus ops versus security divide.
Yeah, these teams often operate like separate islands. Different goals, different tools, miscommunication, duplicated effort, and the classic throw-it-over-the-wall mentality.
And the impact on true CD.
It's crippling. It hampers the smooth integration of workflows needed for a fast pipeline. It leads to a lack of shared ownership. Whose fault is it when something breaks? It delays those rapid feedback loops because information doesn't flow freely.
So how do you dismantle these walls?
Fostering genuinely cross-functional teams is a start. Developers, ops, testers, security folks working together from the beginning of a project. Establishing shared goals and shared ownership. Everyone is responsible for the service in production. Promoting open communication channels like how Etsy famously used IRC for real-time awareness.
Encouraging people to learn skills outside their core role. T-shaped people.
Versatility helps bridge gaps. And sometimes you need to look at strategic organizational redesign, maybe using models like team topologies or UntifigX to align team structures with the flow of value.
Because true CD is fundamentally a team effort, silos are like roadblocks in the pipeline.
They are structural impediments. Any throw-over-the-wall moment breaks the continuous flow and shared accountability needed for automated deployments. Shared ownership makes sure everyone is invested in the entire process, end-to-end. Which leads directly to the next point, evolving change approval workflows and building trust in automation.
The Change Advisory Board, the CAB meeting, feels very anti-CD.
It's fundamentally at odds with the speed and iteration of CD. Those traditional heavyweight change management processes, often involving committee meetings and manual sign-offs, are huge bottlenecks.
So how do you get people, especially management and auditors, to trust the automation enough to ditch the manual approvals?
It takes time and evidence. You build that trust through comprehensive, reliable, automated testing, through robust production monitoring and observability, ideally tied to automated rollbacks, by empowering teams, trusting developers to deploy and review each other's code responsibly, by getting developers more involved in operations, the DevOps ideal, aggressively shifting left on quality and security.
Building that calibrated trust you mentioned.
Exactly. Trust that's aligned with the automation's proven capability, its competence, its consistency. You don't just flip a switch. You demonstrate reliability over time.
So relinquishing those manual change approval gates, that's probably the biggest cultural leap.
It often the most significant cultural leap. It's a profound shift from a human-centric control model to an automation-centric trust model. It means fully embracing the idea that the automated pipeline itself, with all its built-in tests, scans, and deployment strategies, provides sufficient assurance of quality and stability.
Finally, a tough one for many. Audit and compliance constraints in highly regulated industries.
Yeah, regulations like IPA, SOX, PCI DSS add layers of complexity. The stakes are high financial penalties, legal repercussions, and traditional manual review processes clash hard with DevOps speed.
Can you even do true CD in a highly regulated environment?
Yes, but it requires a specific approach: continuous compliance. It's a shift-left, automation-first approach to compliance. You integrate security and regulatory controls directly into the CI/CD pipeline, making compliance an automated, continuous part of the process, not a separate stage at the end.
What does that look like in practice?
Comprehensive security controls, baked-in role-based access, all the automated testing we discussed, SAMmed, DAST, dependent config scanning, detailed, immutable audit trails for every single action in the pipeline, integrating observability data securely for audit reporting, automating test evidence generation and documentation, and using policy as code, defining compliance rules in machine-readable version code that the pipeline can enforce automatically.
So automation actually helps with compliance here.
Absolutely. It makes compliance systematic, repeatable, and auditable. Automated documentation and evidence gathering can drastically reduce validation time without compromising rigor. Continuous compliance turns it from a painful gate into an always-on, almost invisible guardrail. Looking at real-world companies that have achieved this gives us really valuable insights. Companies like Google, Netflix, Etsy, Shopify, they've all navigated these waters.
Right. Google, for example. What stands out from their practices?
Huge emphasis on automation, security, consistent environments, especially using Google Cloud and Kubernetes. They treat integration flows as source code, maintain traceability, often use single repositories per service. They aim for fully automated deployment between environments.
Testing and production clones?
And integrating security, really early linting, static analysis, container scanning, using things like binary authorization and GKE to block vulnerable images. Promoting container images across environments, not rebuilding them. Using advanced deployment patterns, separate clusters, and crucially, preparing for failures.
And the result, faster deployments.
Significantly, moving from perhaps biweekly deploys to multiple times per day without sacrificing quality. Then you have Netflix. Their journey was really driven by needing massive scale availability, fault tolerance for streaming.
Microservices were key for them, right?
Huge. Transitioning to microservices, migrating strategically to AWS Cloud, building a highly distributed architecture. They pioneered chaos engineering.
Chaos monkey, randomly killing servers in production.
Yep, to force teams to build resilient services. They rely heavily on CI/CD tools like Spinnaker, which they helped develop, for automating deployments, high-frequency releases, automated canary analysis, integrating Chaos Monkey. Plus, infrastructure as code, containerization, and a really strong culture of experimentation.
And they achieve incredible uptime despite the chaos.
Over 99.99% uptime deploying multiple times per day. It works.
Etsy's another fascinating case. They were early pioneers, weren't they?
Very early. Famously pushing code to production dozens, even over 50 times a day at their peak. Their philosophy was built around small, continuous changes to minimize risk.
What enabled that speed?
Extensive metric-based monitoring collecting hundreds of thousands of metrics, giving developers direct access to production for troubleshooting. Tools they built like Try for pre-commit testing and Deploynator for one-click deployments. Lots of automated testing, A/B testing with feature flags, they called it switchboard, Trunk-based development.
Using IRC for communication.
Yeah, for central awareness. And notably, a no rollback fix forward mentality, showing immense confidence in their ability to fix problems quickly. They later evolved to use blue-green with a canary-like ramp-up. And finally, Shopify. They handle massive e-commerce traffic.
Up to 80,000 requests per second. Wow.
Yeah, their platform stability and scalability are paramount. They have a strong DevOps culture, comprehensive CI/CD pipelines with all the testing stages we've talked about, automated staging and production deploys.
Using Docker and Kubernetes. Custom tools.
Yep, leveraging containers and orchestration heavily. They develop custom tools like ShipIt for web and mobile deployments. Also followed trunk-based development, strong focus on monitoring and observability with tools like Prometheus, Grafana, ELK Zipkin, and critically, they empower developers, trusting them even with mechanisms to bypass CI restrictions in emergencies.
So faster build times, streamlined development.
Up to 50% faster mobile build times, for example. It shows the payoff. So wrapping this all up, the journey to true CD, it's clearly not just about installing some tools. It's a deep organizational transformation. And the biggest blocker really is often that lack of unwavering confidence. Confidence in the automation, confidence in the testing, confidence in the organization's ability to manage change and recover quickly when things go wrong.
And that point about relinquishing manual change approval gates,
They
that feels like the crux of the cultural shift, doesn't it? Moving from human control to trusting the automated system.
It's a profound shift. And that trust isn't granted. It's earned. Built incrementally, deployment by deployment, through consistent positive outcomes and demonstrating that recovery is fast and low impact when needed. So based on everything we've unpacked, what are the essential best practices for achieving true continuous deployment?
Okay, let's summarize. First, prioritize automated, reliable testing. Massive focus on unit and integration tests. Hunt down and eliminate flaky tests. Use those advanced shift-left techniques like contract testing and static analysis.
Second, implement robust deployment strategies. Use canaries, blue-green, shadow deployments, leverage feature flags heavily to decouple deployment from release, manage risk actively.
Third, establish comprehensive observability. Monitor everything. Collect metrics, especially DORA metrics. Use structured logs, distributed tracing. Get real-time insights. Set up actionable alerts.
Fourth, automate rollbacks and ensure rapid recovery. Design for reversibility. Automate the rollback process. And crucially, test your rollbacks regularly, like fire drills.
Fifth, foster a culture of collaboration and shared ownership. Break down those silos. Get dev, ops, security, testing working together. Build collective accountability for services in production.
Sixth, address resistance to change systematically. Communicate the why relentlessly. Get executive buy-in. Involve people early. Build that learning culture, that psychological safety where it's okay to experiment and learn from mistakes.
And finally, seventh, integrate security from the outset. DevSecOps. Embed automated security checks, assess, desest, dependency scans, config checks throughout the entire pipeline, make security continuous and everyone's job.
That covers the core principles. Now, for practical application, how does a team actually transition from maybe having CI and some automated testing to full true CD? It's iterative, right?
Right, it's a journey. Let's outline a possible step-by-step guideline. Phase 1, foundation building and trust establishment.
First step here is assess your current state. Where are the bottlenecks, the manual gates, the areas with low automation? What's the culture like? Get baseline DORA metrics.
Then, strengthen CI and your foundational tests. High coverage, high reliability for unit and integration tests. Kill those flaky tests.
Adopt that shift-left mindset culturally. Train teams, encourage cross-functional work, foster shared responsibility for quality.
And implement basic observability. Start collecting key metrics, logs, traces. Set up some initial alerts for critical failures.
Phase 2, introducing controlled automation and risk mitigation.
Okay, now start automating the deployment mechanics themselves. Make sure deployments are fully automated, repeatable, idempotent.
Pilot those advanced deployment strategies. Start small, maybe with non-critical features using Canary or Blue-Green. Implement feature flags.
Automate rollbacks, develop the procedures, automate them, and say it again.
Regularly test them. Make sure they actually work.
Integrate shift-left security tools early in the pipeline. SSA, dependency scanning, config linting.
And refine your feedback loops. Enhance monitoring for more immediate, actionable alerts based on what you learned in Phase 1.
Phase 3, scaling confidence and eliminating manual gates.
Now you expand those advanced deployment strategies to more critical systems as confidence grows based on successful outcomes.
Leverage ephemeral environments for E2E testing. Get that parallel isolated testing going to remove bottlenecks.
Continuously monitor and analyze your DORAR metrics. Use that data to drive further improvements and identify the next bottleneck.
Keep working on the cultural barriers. Continue fostering psychological safety, shared ownership, open communication. Evolve traditional change management towards automated governance based on pipeline evidence.
And then the final step, really, gradual removal of manual gates. As trust builds, as the automation proves itself reliable and safe, you start removing those manual approvals incrementally.
Yeah.
Not as a forced mandate, but as a natural outcome of having a robust, trusted system.
By systematically tackling both the technical and the cultural sides, it really does seem possible to make true continuous deployment a reality.
It is, and the payoff is huge: faster innovation, higher quality software, and much greater business agility.
And that wraps up our deep dive into the fascinating, sometimes daunting, but ultimately achievable world of true continuous deployment. It really is a journey that changes how we think about building and delivering software, proving speed and safety can coexist. So what's the big takeaway for you, our listener? Maybe it's that often the biggest hurdles aren't just code or tools, they're human. It comes down to building trust and automation in each other, breaking down those silos, and learning to genuinely embrace change one small, automated step at a time, building a system so reliable it feels safe enough to deploy itself. We really hope this exploration gave you a clearer roadmap, maybe sparked a few aha moments for your own journey. For more deep dives into the cutting edge of technology, architecture, and beyond, please remember to subscribe to Joy of Architecture. Until next time, keep building with confidence.